In this video, we're going to explore our first tension problem. So let's set up a scenario. So we have a situation below where we're going to calculate the acceleration and the tension in the string. So what have we got? Well, basically we've got a 1 kilogram mass acting downwards, which is held by a string, goes over a pulley and pulls a 0.8 kilogram trolley on a frictionless surface. Now this is accelerating. So let's look at the first solution, which is working out the acceleration. So we know that the force acting on the 1 kilogram mass is the weight force, which is acting downwards. This is made up of 1 times 10, where 10 is g. So the weight force acting downwards is 10 newtons. Now this weight force basically causes the whole system to accelerate. Now the whole system, as we can see from the diagram, is basically going to be made up of the 1 kilogram mass joined to the 0.8 kilogram mass by the string. So F equals ma, as we know, and we know that the weight force is going to actually be causing the downward motion, and we know the weight force is pulling. The combined masses of 0.8 plus 1, so it's the two masses, which is 1.8 kilograms. So acceleration is 10 divided by 1.8, which gives me 5.6 meters per second for the acceleration of the whole system. So in solution B, we're going to calculate what the tension is in the string. Well, we've sort of got two tensions, one joined to the 1 kilogram mass. So let's look at that first. So we're just going to look at the 1 kilogram mass first and see what's happening there. Now basically what we know is that the tension force is going to be made up in this instance of the weight force pulling it down plus the acceleration of the force of acceleration. But we've got to take this away because we've got less of a force applied on the weight mass because this is being pulled by the 0.8. So basically we get 10 minus the F equals ma, which gives me 4 newtons acting downwards. Now let's just have a look at what happens at the 0.8 kilogram mass. And this is going to be under the same acceleration, but it's only going to be the force of acceleration, which is going to be pulling it across. Now this should actually be exactly the same, but just acting in a different direction. Now if we look at the 0.8, we've got a support force acting upwards, Fn, and we've got a weight force acting down, but we know that the support force equals the weight force. So the only force which is generated is that by the acceleration. So the tension in the string will be equal to ma, which is 0.8 times 5.6, which again equals 4.5 newtons, and that's going to the left hand side. Actually it's 4.4 acting downwards. So what we find is that the two tensions, the tension acting downwards of the 0.1 and the tension in the 0.8 are going to be the same. Okay, thanks for watching.